guys, welcome back to chapter 9. In the last video, we took a look at Hess's law. So Hess's law tells us that the enthalpies of the intermediate steps, if we add them together, that will be the enthalpy of our overall reaction. And we looked at an example where we reacted things like A's and B's and C's and D's, right? So what I want to look at in this video is how do we add together actual chemical equations. So sometimes when I put like actual molecules on the paper, things get a little bit more challenging. So I want to do this problem first, and then in the next video we'll do an actual like full-blown Hess's law problem. All right, so in this one we are going to look at these two elementary steps. So these are the steps. We want to determine what is the overall reaction. So as a reminder, to get to the overall reaction, we need to first identify what we call reaction intermediates. So things that are produced in one step and then consumed in a later step. That reaction intermediate will not show up in the overall reaction. So looking through these two intermediate steps, I see carbon monoxide is produced in step 1. So let me see what happens in step 2. Oh, there it is. It's consumed in step 2. So that would be an example of a reaction intermediate. Water here is produced in step 1. I don't see it consumed in step 2, so that can stay. That's fine. And I see this half a mole of oxygen is produced in step 1. And I see a half a mole oxygen consumed in step 2. So that also would be an intermediate. So the first step is to identify reaction intermediates. And then from there, that was a horrible arrow. From there, I'm just going to bring down anything that's left. So over here on the reactant side, I've got CH4. Plus 2 molecules of oxygen, and nothing from the second step because both of those got crossed out. And then in the product side, I've got water from the first step. And then from the second step, we've got carbon dioxide. So that is our overall reaction. We identified intermediates, canceled them out, and then we just wrote everything that was left. And now the easy part for Hess's law is if I know the enthalpy associated with each of those steps, I can then get the enthalpy of this overall reaction by simply adding these two values together. So I think I can do this by hand. So that's 10, 9, 6, 7, 8. And that is negative, so I just added two negatives together. So the enthalpy change associated with this overall reaction is negative 890 kilojoules. Now in the next video, what we'll see is it's difficult to measure enthalpy experimentally. So sometimes when we look at these elementary steps, they won't necessarily be in order. So we might have to do some manipulating of the elementary steps to get to the overall reaction. So in the next video, we're going to ramp it up a little bit and take a look at a full-blown Hess's law problem. I hope you guys found this helpful.